broadcasting live through YouTube and in-game. Turning off in-game audio as soon as I see the stream show up. Audio as soon as I see the stream show up. Audio. Okay, it is March 8th, Monday. We're going into it is March 8th, Monday. We're going into it is March 8th. Almost there. That's what I want. Okay. All right, so we are broadcasting in game. You should be seeing the video. I cannot see the video because I turned off media to prevent inception. I'm turning off the music for now, and we are in the world. All right, here we go. So great, looks like you guys found a seat and you're able to see the game okay. Josh was flying around for a moment. And Landon's over in the corner. Landon, you're welcome to join us. Do not feel like you have to be in the corner. YouTube window is kind of shrunk in 1/4 of the board. Sam, did that get adjusted? I intended to fix that there. If that worked out, that would be great. Yeah, that should be adjusted. Let me see if I can. All right, I'm going to go Inception for a second to make sure that gets corrected. Stand by. And leaving Inception. All right, I think that if it's not corrected, it should correct momentarily. I think it's just laggy. Okay. All right, that's a bit much, but kind of fun. A reminder that you can turn down the audio for the fire if it's too much by turning down the sound slider in the upper right. All right, we are starting on chapter 16 today. And while 16 is not on the exam that's on Friday, it is helpful to try and understand a little bit about what 15 is about. So 15 introduced a number of different kinds of data structures that you'll need to practice with a little bit on your own. And hopefully the Techni will give you an opportunity to do that as well. In chapter 16, what I want to do is I want to work through the implementation of some of the Java collection frameworks. Now, you don't have to implement the Java collections frameworks. They're available for you. You can just use them by importing them from java.util in most cases. Nevertheless, understanding how they are implemented is very important for understanding the efficiency of the different data structures. And so what I want to do is I want to spend some time trying to implement a few of them, not in their full, complete implementation, but enough so that you get a sense of why efficiency varies depending on the different kinds of implementations that you might choose. Faith live stream should be going okay. In game, you know what, just to make sure that since we're doing something a little bit odd, let me just make sure that you've got it. All right, so what I want to do then is I want to take a sec and get everyone into Eclipse. So let's take a second and do that. Let me find my Eclipse. There we go. All right, and some of you all have made it okay. Let me close everyone's pyramids that I was grading. Okay, and we're sharing this project, and we've got a number of people that are in there. Let's see what code's actually present. Mostly we just want the skeleton, or we just want the hello world to make sure everything's working. So let me get rid of the stuff that's there from last time, deleting a few things. Let me go through and restrict to read only for Adeline and Ben, Carson and Faith, Landon and Matthew. Wow, why is it going so fast today? What a good day. Trent and Thomas. And let me do a round of invites here. right, and then while you all are working on your invitations, I'm going to go ahead and create a class over here that we're going to work with. And we're going to create an array list. All right, but I don't want you to confuse it with the array list that's implemented by Java, so we're going to give it a separate name. And because I can't think of a better name right now, we're going to call it DP array list. This is to differentiate it from the array list that's available in Java. We won't give it a main class for now. Go ahead and finish. And so we have an empty class there. Great. All right. So let's talk about this academically before we do some implementation. All right, so I'm going to put on screen here slide notes. All right, so we're just to reiterate, we're doing chapter 16 today, and I asked my wife to. I didn't have any Dodger pictures ready to go, so I asked my wife to send me some emergency Dodger pictures. So I've got some here from a few moments ago. That's Dodger. He's getting breakfast right here. You can see in need Dodger pics ASAP. He is looking very sus right there in our kitchen by the counter, and that's because apparently we're having crepes for breakfast at home. I'm not, but the rest of the family is. So Dodger's trying to get in on the action as he is wont to do. Dodger report for this chapter is Dodger is in good shape. He's feeling healthy and doing well. The wart on his nose continues to get bigger and gross us out. Basic data structures, we're going to be looking at an implementation of linked list and array list. And although our textbook begins talking about linked lists, what we're going to do is talk about array lists because I think that it's a little bit more of a straightforward transition before we talk about linked lists. And through this implementation, we're going to understand the efficiency of those two implementations and then see how easy it is to build a stack and queue type once we have a list implemented. Like to look a little bit about hash tables and understand the efficiency of their operations, but we won't get to that until after spring break. All right, so let's take a look at our array list. And the thing that we're going to do with our array list is we're going to implement our array list using a strategy called a wrapper strategy. And the wrapper strategy, W-R-A-P-P-E-R, is a strategy in which you create one class that uses another class as an instance variable. It is a private instance variable. Maybe it's a little bit like an eggshell, where you're implementing a class as the outer eggshell, but you're using another class that's maybe like the yolk of the egg inside. And while you're only providing an interface through the shell of your egg, you're using the full power of a class internally, which is the egg yolk. No one outside of the egg can get to the egg yolk, though, because you are wrapping it. And you're using it, but you're not allowing anyone else to use it. So it's part of the implementation of your class. So what we're going to describe now is we're going to describe the implementation of an array list. You are acting as the systems programmer so that someone else can use your array list in the way that we believe an array list should be written, such that it has a comparable, has an interface that's like an array list. So we know that what an array list does is it is a data structure. It is an object-oriented data structure, and so we use it as we keep a reference to one in order to use it, and it is an array of elements. And we want this array to be large enough. Internally, it's going to have an array. And internally, we want the array to be large enough to hold everything that our API programmer wants. And we don't want them to have to think about the size of the array that we're using. So our implementation for array list is going to use this previous idea that I introduced of an array, not an array list, of an array that has a capacity that differs from its full size. We're going to use all that mechanism internally like the yolk of the egg in order to implement the array list, which is going to be more powerful and is going to be outside. The way we're going to do that is we're going to keep track of the size of the array internally. And when the user wants to have space that's not available, we're going to make it bigger. We're going to increase it for the user. And they're never going to know it's happening. It's going to be part of the implementation. So our array list will have an instance field that's holding both the current elements and the current number of elements, the capacity and the elements themselves. So this diagram here, the red shows the two chunks of memory that we have allocated in order to implement this. The one on the left is the array list. That's actually going to be the DP array list that we're going to implement. And we're going to have an instance variable, which is the current size of the internal array, and a reference to the internal array, which will be an array of objects. So we can put anything in it. And in this case, you can see we're putting strings in it: Tom, Diana, and Harry. Can we just have a moment for the Megan and Harry interview? And why haven't I seen them in Montecito yet? And why am I not dedicating more of my life to stalking them? Those are the questions that I have after the interview last night. All I can say is hashtag bombshell. Nevertheless, regardless of what we're going to put in there, strings or whatever else we might want to put in there, we're going to prevent the user from doing it directly. We're going to use it as our internal implementation. Okay, so here's the shape of what we're going to be doing. I'm going to go ahead and type this in for us so we can kind of understand what's happening. We're going to have an array list, and we're going to have an array of objects, which is our private components. We're going to have a size for that. We're going to have a constructor of our outer array list, in which we initialize our empty array to have some initial size, put nothing in it, and make our current size 0, so nothing's stored in it. And then we're going to make a size method as well. So let's shift gears to Eclipse and see how we're doing with Saros connection. And all right, clean this up a little bit. Go through and make sure that we've got everyone read only just for logistics sake. All right, a few more read only. All right, anyone else need a connection that they know they just restarted Eclipse or dropped out, or their dog tripped on their Ethernet cable? Sure, who's speaking? Probably Sam. Yeah, there you go. Give it a sec. All right, there you go, great. All right, looks like Sam's connected. All right, wait for that window to go away. Enjoy this moment to take a sip of coffee. And you know, I think now that I'm about to write code, I want to write the code in such a way that it is more like the way that I would really write code, which is I would start here by doing a JUnit test before I've even written anything. So let's go ahead and do that. Let's create a new JUnit test, and this is called test-driven development. And in test-driven development, what you do is you write your tests before you write your code, because that formalizes what your design is. So let's go ahead and do that. And let me just make sure that my project is set up right so that you can run these JUnit tests. The JUnit test is, but I don't think the library is. All right, there we go. Just to make sure, try running your hello world on your computer and make sure it prints out hello world. And if it does, then everything's good to go. If it's systematically not working, can you indicate as much in the chat, and I'll try and take a look. All right. So we want to write a test for this. Okay, so the first thing we're going to do is we're just going to test the constructor. What we want to make sure happens is that we can create a new element. So we're going to create a new DP array list element. We'll call it A for array, and we'll call the constructor. Oops. DP array list. All right, and that's going to be a constructor that will create a new array list. And what we're going to test is we're just going to make sure start equals that 0 equals a dot size. Now we haven't even implemented any of these things yet, and so we're going to get a bunch of errors from Eclipse, but we know what we're working towards. When I try and assert that the size is 0, the Eclipse says, hey, you don't even have a method called size. So I'm going to use a fast hotfix and ask Eclipse to make a stub for size for me. So this is another benefit of working through the tests first, is that you can have Eclipse write out the stubs for everything that you expect. All right, so we've got the size, we've got the constructor, that should work okay. Let's see, anything else we want here? Let's go ahead and create a test for a getter and a setter, because that's a pretty standard piece of how an array list works. So let's test access. Okay, so we're going to want to do something like create an array, and then we're going to want to add something to it, and we'll add string. And then we'll add another string. It was Billy the gecko, right? Billy the gecko. I think it's Billy the gecko. Remind me if I didn't get that right. Now what we want to do is we want to assert that the size is 2 if everything is okay. So that's our first test. And then we want to assert that the elements are correct. So all we're doing is making sure that everything is working correctly here. So we want to make sure that if we do a.get0, we get what we think we put in first. And then we want to make sure that Billy the gecko is what we got in second. And then we're going to do some changes to our array to check to make sure that works. So we're going to set position 0 to, I need another pet. Who's got another pet for me? I'll answer that. Okay, so Josh asks, what's the point of having an array hold the current size when there is a size method for the array list? Um, the point is that we're assuming that there's no such thing as an array list. What we're doing is we are implementing array list as if no array list exists. And so we're doing this because I want to show you how an array list is actually written, building on technology that was available previously. So I don't know what's with all your weird mythical animals. Gosh, I just wanted an actual animal. Gosh. Okay, we'll do Lucy the cat. I like Lucy the cat. All right, and then we want to make sure that position 0 is now Lucy the cat. Josh, did that answer the question? A big part of what's happening right now is we're trying to let me go YouTube for a sec. Let me go in game for a sec. All right. So here's a bunch of methods that haven't been implemented yet. I'm going to ask Eclipse to stub it out, create that method add. So we'll have to implement that later. Here, let me shift that over here so we can see this. Get a little bit more screen real estate. All right, and give me a size method, give me a get method. That should be everything. Save it all. Now it's not clear that it did exactly the way I wanted it to do, so we'll just make sure of that. And set, we don't have set, so give me a set. All right. So previously, when I was showing you what it was that we were going to implement, I gave you a little bit of code. So let's make sure we have that code present in our array list. All right, so when we create an array list, we're going to need a constructor, and we're creating this array list from nothing. And so we need to have some kind of a current size, some sort of initial size. Let's go ahead and create final int, and we're just going to call it initial size. How big, how much capacity are we going to have at the beginning? And we'll say it starts with 10. And so when we call our constructor, you can see that's a constant. When we call our constructor, we're going to say that the internal elements, I'm going to call it something a little bit different. I'm going to call it data. We're going to set that equal to a new array of objects whose size is initial size. We haven't defined data yet, so I'm going to ask Eclipse to make that for me by creating a new field called data. Field is another word for an instance variable. So there you go. Eclipse made it for me up there on line 5. Go ahead and make this private. Do I care how big? I'm gonna make that private. I don't want other people thinking about it. Okay, and then we need to set, sorry guys, excuse me. Then we need to set our current size equal to how much data is currently stored in our array. And when we call our constructor, there's nothing in our array list. So remember, from the perspective of someone who's using our array list, they're going to call the constructor. They want to reference back to this object, but they just made the list. There shouldn't be anything in it. And so these settings for our data give us a space to put things into it later if the user of our array list wants to add something, and we know how many things are currently in it if we have a current size variable. So keep track of it as an int, keep track of our data as a size. Man. Trader Joe's went shopping yesterday, regularly go shopping on Sundays for groceries. I'm the grocery shopper for our family. Trader Joe's has this ice cream now. It's a coconut ice cream that is coffee flavored, like cold brew coffee flavored with boba in it in the ice cream. It's really good. It was really surprising. So I was up too late having had coffee ice cream later. But they also had this snack, which was dried mushrooms. And that sounds really weird. They were surprisingly good, even though they were like freeze dried mushrooms. Unfortunately, I think I'm coughing all day today because of them. And also, I totally smell like mushrooms. So stay away from me if you don't like mushrooms. I think that's why I'm coughing. Sure seems like it. All right. So the easiest thing to try and implement here is probably going to be the size method. And the reason why this is so easy is because we have an internal variable called current size, which is keeping track of how much data we've actually got. Now, we're not allowing the user, the API user of our array list to know that we have a variable called current size. All they know is that they can ask for the size of our array by calling the size method. We're getting a little bit of a complaint here from Eclipse because it says, hey, you need to return an integer, and what you're returning is an int. You're returning a variable of primitive type int, and you said that you were returning an integer. And so I'm going to use a conversion function to make an integer into an int, which is integer value of, and then current size. How'd that work? Why do I have to rename the method? Link all references. Oh, I've got another one down here. Okay. Actually, maybe that wasn't necessary then. It's because I had two of them, but maybe it's going to box it for me automatically. Let's see. Oh yeah, it automatically boxed it for me. Okay, so in any case, this is what that's going to end up doing internally. It calls that in order to turn it into an integer. All right, so that's the easiest thing I've got. You can see Eclipse is complaining about line 5 because I'm never actually using the internal data array yet because I haven't implemented add, get, or set. Over in the test, you can see that we've implemented enough now that that test constructor should work because we have the constructor built and we have the size method built. And so let's go ahead and right click on DP array list test over on the left, and I'm going to do coverage as a JUnit test. Save everything up and see what happens here. All right, so I see that my tests are run and I get a line, I get green indicating that the lines were run. That doesn't mean it passed. That just means that the lines run. That's good. If I look down here on the left to see whether or not it actually passed, I'm able to identify that test constructor is green, and so the test passed, that's why it's green, and test access failed because it is blue. I can actually look and see that when I was calling test access, it was able to call the constructor, that's why it's green. It was able to call the add method, that's why it's green. It was able to call that, that's why it's green. As soon as we tried to assert that the size was equal to 2, it threw an exception because this did not pass the assertion, and so no more code was run from 20 on because it failed because of the exception, so it didn't run anymore. And the reason why it failed is because the add method isn't implemented. And so when I add two things and then call the size remains 0. And I think if I come over here and I double click on this, I double click on the assertion, it'll show me what happened. Yeah, there you go. So it shows me, it's highlighting the line in blue that failed because I double clicked on the failure trace at the top. It's highlighting the line that failed in blue, line 20, and it's showing me the result comparison down here in this pop-up window. On the left is whatever the first parameter was, and by default, that's considered what's expected. It says you expected a 2, but what you actually got was the result of a.size, which ended up being 0. And this is why it failed. All right, so a reasonable thing to do might be to implement add next, but what I want to do before I do that is I want to create a helper method internal to my class that's going to help me to keep track of whether or not I have overstepped the bounds of the current data that I have allocated. I know that the user of the DP array list class is going to just add stuff willy-nilly, not fearing that they run out of space, because the idea is that I'm going to keep track of the space for them. However, internally, I may actually run out of space in my data array. And so I need to make sure that there's housekeeping internally in my implementation to deal with that. So what I'm going to do is create a private method, and it's not going to do anything. It's just going to, it's not going to return anything, but what it's going to do is check to make sure that we haven't gone out of bounds. It's going to take an index for me. We'll give it a better name than n. We'll say check index. And what we're going to say is we're going to say if check index is less than 0, well, that's a problem because we have to have positive indices when we ask for elements in our array list. Let me define this a little bit better here. Use a Java doc and say throws an exception if the check index parameter is out of bounds for the current data in the array list. So this is like if you ask for element 1 million and you haven't put any data in it yet, what you would do is you would pass in check bound 1 million, and if that's bad, it's going to throw an exception. So if the thing we're checking is less than 0, that's a problem, or if check index is greater than or equal to current size. Let's take our test over here so you can see the whole thing. All right, let me space it out so we can see it. Because the position, the number current size is going to have the index where the next data element is going to go, because we're starting at 0. So when we start, current size is going to be 0, and the next element is going to go at position 0 in data. So that works out nicely. And if there is a problem, we're going to throw an exception. New index out of bounds exception, and this is a standard exception that comes with Java, although we may have to include it here. Boop. All right. And it's going to say, hey, do you want to explicitly indicate in the method signature that you are throwing an exception? And let's see. Oh, no. Add parameter to new field. I'm trying to scan why I'm getting this warning. Assign parameter to new field. Not exactly sure why it's giving me this warning. It says, oh, it's giving me the warning because we never use it. Okay, so we're not using it yet. You're not using the method yet. We just haven't had a chance to do that. All right, so if our index is the wrong size, we're going to throw this out. And now we are able to do a few more things. Now that we can check our bounds, let's go down and implement our get method. When someone who is using our array list wants an element, we'll simply return it to them. We will say return data sub I, just like as if they were using an array. However, we have to check to make sure that they haven't asked for something that's out of bounds first. So we're going to call check bounds on I. And so if it's bad, or did I spell it wrong? Check bound. I want it to be called check bounds. I'm going to make it to check bounds. All right, so if there is a problem on line 35, an exception will be thrown and we won't run anymore. If there's not a problem, then we're going to return the data that were stored internally in data sub I. All right, so that's good. That doesn't give us the ability to write any more tests though, because in order to test get, we actually have to be able to implement add first. Otherwise, we can't really test it. So that would be a good one to do next. Since we're thinking about gets and sets though, let's go ahead and do the set, since that's pretty straightforward. Now, when Eclipse made this method for me, it made it based on the test. And in the test, I was setting strings. But actually, I want my class to work with any objects. And so this is a little bit like saying you can pass in anything you want here as long as it is an object reference, because all object references are inherit from object. So object is the superclass of all references. And so this is earlier in the class, someone asked, in Python, you don't have to specify the type of an object. In Java, do you have to do that? And the answer is yes, but here's kind of the exception. We're creating an array list that can take any kind of reference by saying it works with the object reference, which is just the superclass of all of them. And since we're not doing anything with the data, we're only a repository for the data, we don't need to know what's in it. We just need to know that it's a reference. So similarly, for set, we are going to first check the bounds. So set doesn't return anything. It's changing. It's a mutator, so it's not going to change anything. It's not going to return anything. We're just going to check to make sure that the index is okay. And let's change this variable name so that we reflect the fact that it is an index. All right, we'll check the bounds of the index. And then what we are going to do, call this new data. We're going to change. So check the bounds is going to make sure that everything is okay with our boundaries. And so we know that when our API programmer is asking to set something in the array list, because we are able to get past line 40, we know that the index that they are asking to use is part of the valid data that they have already put in the array because it is less than current size. And so when they ask to change the data that is at index, we're able to do that once we get past line 40. And so we can do that pretty easily just by saying data sub index equals new data. We just have to make our, okay, new data is a little bit confusing because that sounds like I'm calling a constructor and I don't want to confuse you. So I'm going to call it alt data. Alt data. All right, great. So far, so good. As you look at how get and set operate, I want you to recognize how much computation is happening here. And it is relatively simple. We'll say index, return the data at position index. It is so simple that regardless of what index is, this method is going to take a constant amount of time. It doesn't matter whether index is large or whether index is small. There's no looping behavior going on here. There's no other methods that are called except for checkbounds, and checkbounds is also has constant time. It's just doing one check and throwing an exception if there's a problem. And so I'm just going to put a note here that says the efficiency of this operation is constant. And we use a notation big O1 in order to describe that. Big O stands for it stands for the order of efficiency. It's not really a function, it's a mathematical notation. And by putting 1 in there, what we're saying is no matter what the size of our data is, no matter what the parameter is, this method is always going to take the same amount of time. And that's also true with our set method as well. It's always going to take the same amount of time because there's just nothing that causes the time to be variable here. We set some data, we change the memory, it's all fine. The efficiency, let me just make sure my Java doc's okay. The efficiency of this operation is constant, parameter index, and parameter alt data, and returns nothing. And so this method replaces the data at position index with alt data. All right, let me go in game for a second, see if there are any questions about where we're at. Now we're going to start working on some trickier elements. We're going to work on a method to add, and we're going to work on methods to remove. So let's let's go ahead and make our add method. And just to be clear, what add is doing is it's adding it to the end. So let's make that clear in the Java doc. Adds a new element to the end of the list. All right. It can be anything. It doesn't have to be object, and we'll call it alt. I don't want to call it alt data because now it's not alternative. We'll call it fresh data because it's fresh. Hey kids, fresh data. The new data to add to the list. Okay. So here's our situation. We have we have an array up here at the top that we have started off with a size of 10. We know that at various points, the user of this object may have added data to it, it may have taken data away, and regardless of what the state of our array is, when they call the add method, when the API programmer calls the add method, we want it to be able to add this data regardless of what the current state of our data structure is. So let's do the straightforward thing, which is to say we're going to have the current size, actually let's say data subcurrent size is going to equal the fresh data. And now current size will be increased by 1. And great. That seems great. Does anyone see any problems with that? Let me be more clear. There is a problem. What is the problem? Use the chat function to see if you can identify what the problem is here. Yeah, Dee says we haven't checked to see if the capacity is enough. That's right. And so when we start this, it is fine at the beginning. And in fact, what we'll see is we'll see that, oh, our test will run fine now because we have add and we have get. So I think if we run our tests, we've implemented everything. So I'm going to run it. Let's see, why did it fail? Oh, because I misspelled gecko, the geeko. Billy the geeko. All right, let's run it again. All right, we passed our test. So everything is working fine, but we're going to run into this trouble. And let me demonstrate what the trouble is. And I'm going to write a test that particularly exposes the trouble so that we can not have a regression test. To test our capacity, I'm going to come back here and I'm going to make our initial size be public. I'm going to allow people outside of our class to be able to see what the initial size is. I'm going to do that so that I can write this test. So here's what I'm going to do. I'm going to create an array list and I'm going to create a loop. While I is less than a dot initial size, I'm going to say I plus plus. And I'm just going to go ahead and say twice the initial size. And I'm going to say a dot add. We'll add Dodger. And we're going to make sure that the size is a dot initial size times 2. Why is it complaining about I? It's complaining about I. Okay, I'm going to talk it out to try and understand what's going on. I have a loop, and I'm using a variable called I. I'm initializing it. Oh, it's because I didn't initialize it. There we go. Great. It's a funny thing. I don't know if you've noticed that I do that. I'm a little intentional about that when I'm coding. And it's a little different when you're teaching and you're coding, you're doing live demos or something. You'll run into a bug like I just ran into. You see some support from the IDE telling you that there's a bug, but you can't really figure out what's going on. part of that is a little bit like something analogous to stage fright, where I know that you all are watching what's happening and I don't know what's wrong necessarily, and it's easy, but in the moment, like I can't parse what's happening. And so what I do, that thing that I do when I stop and try and talk it out, is I'm trying to be very explicit about my thought process and I'm verbalizing it so that you can hear what I'm saying. And I'm doing that intentionally so that you can learn my debugging process, even though it's a little bit weird. Occasionally I'll do it if I'm by myself, but most of the time I don't run into this problem when I'm by myself. And so what I'm doing there is I'm walking through and I'm describing the code and then I'm listening to myself as if I'm a student listening to a teacher and evaluating what I'm saying. And in that process, it slows my brain down enough to consider the assumptions that I'm making, consider the code that I've written, and I don't know what I'm doing. I don't know exactly what's happening there, but something about that process of stopping and explaining what's happening helps me to find bugs, particularly when I'm teaching. So what we expect here is we expect that our array list is going to have a whole bunch of copies of Dodger. This is fine. We don't know because when you write a test, you're acting as an API programmer. You don't know exactly how many copies are going to be there because you don't necessarily know what initial size is. But you do know that at the end of it, you know how many should be in there based on referencing it on initial size. But if we run this, we're going to run into the problem that I was referring to and the problem that Didi picked out, which is that our capacity is not varying. So it worked okay for a little while. We got to the situation where we were able to add some Dodgers, but then we got to this error, and the error happens here, and the error, if you look over here, is that we get this array index out of bounds exception. Index 10 is out of bounds. So we kept adding things, and then at some point, current size got to be 10, and now we're out of bounds because the array that we started with is too small. So what we need to do is we need another helper method, and our helper method we'll just call grow if necessary. And our helper method grow if necessary is going to be private, and we're going to just use that as a way to increase the size of our data if it's needed. So I'm going to ask Eclipse to make that for me, and it's going to create a stubbed out method right here. So what we want this to do is we're going to say increase the size of the internal data storage if necessary to add one more element. All right. So the way that you know if you need to grow is if your capacity isn't big enough. And so if it turns out that if your current size is equal to the size of the length of the array that you currently have allocated. Remember, data.length is how much space you've allocated, so it's going to be 10 initially, and current.size is how much is stored. Current size is the index of the next place where you want to store the data, and it's the size. So if current size is 10, then we have data in we have information stored in the variable data from position 0 to position 9. Data.length is equal to 10 in that case. Current size is equal to 10. And that means that if someone were to add one more element, we would try and put it in position 10. That's what current size is equal to. We get this array index out of bounds error because data.length data isn't big enough. Data.length is equal to the place where we want to put it. Now we don't have a magic answer to this because the whole point of ArrayList is to do this growing process automatically, and we don't know how we don't have that capacity. We have to build that capacity in. And so what we're going to do is we're going to just do that resizing on our own. And we're going to say we're going to create a new array. We'll say object new data, which is going to be, we're going to use it to replace it, is going to be a new array whose length is 2 times our current length. So we're going to double, when necessary, we're going to double the amount of storage that we have set aside to keep track of our data. Great, so now we have 2 arrays. We have one called data and one called new data. New data is a local variable. We need to make sure that we put the correct data into new data so that it reflects the data that was already there so the user of our array list doesn't lose data. So that's easy enough. We'll just say for int I equals 0, while I is less than data.length, we'll say length I plus plus, and we will say new data sub I equals data sub I sub I. Clean up the code, make sure the types are right. All right. So what we're doing here in lines 49 to 51 is we're transferring all the old data in the old array into our new array. And now we're just going to swap it out. We're going to say the data that we're keeping track of is the new array that we just made. So overall, grow if necessary, check to see if there was space to add more data on line 47. If there was, then no problem. We just return. The if statement's false and we just return, having done nothing and returning nothing. But if we have run out of space, then we have some work to do. And that's in line 48 to 52. We create a new array that's twice the size of our current internal array. We transfer the data from the old array into the new array. And then we change the reference from data that was pointing to a smaller array. Now it's pointing to the same place as the new data. And now we're able to grow. So now if we go down to where we're adding our data, go up. If we go up to where we're adding our data, now you can see that in line 36, the first thing that we do is we expand our array if needed. And then we know when we get to line 37 that we've got space to put our new data in. So we should be able to pass all of our tests now. So I'm going to go back down to our JUnit test. I'm going to say, okay, let's run it again. If we correctly implemented that, then we'll pass our test. There we go. We passed the test. You can see that the constructor and the access, that you can see that the lines are red. That's not because we failed the test. This is a coverage coloring. That means we didn't run that code. And as I think about that, oh no, I didn't run the test constructor code. Oh no, I didn't run the test access code. That's okay. I didn't ask that to be run. I just asked for a test capacity to be run. And so that's all that was run. If I click here on the class and I right click and I go down to coverage as, then it will run all of the tests that are present in my test class. You can see that all of them get run and all of them are passing. So this is great. So far, so good. Let me pause, see what kind of questions we've got. Shifting to in-game for a sec. All right, broadcasting YouTube. So the question was, does it make sense to double the size of the array when we run out, or does it make sense to increase the array by 1 every time we need to? And this is a great question because it gets to the heart of how efficient this whole implementation is. You can imagine that if you were just going to add and set data and you were never going to go over your initial size, then you would never call grow. And if you were filling up an array, and let's say you were going to put 100 elements in the array, and you were just going to add things one at a time, then to call grow if necessary every time you started adding something over your initial size would be inefficient. And the reason why it's inefficient is because of line 49 to 51 here. This copying operation, unlike the other operations that we indicated were constant time, this copy operation is not constant time. To copy this data from one array to another array takes not a constant amount of time, but the amount of time that's based on the amount of data that you've got. So we say that the amount of data you've got is n, and so this is actually let me write this down. Efficiency of this operation is order n. which means that it varies based on the length of your array. If you just do this, let's say you're going to fill up your array with 19 elements and you're going to add them one at a time. If you start with an array that's size 10 and you add 10 elements to it, you're never going to do the expensive work in grow if necessary. You'll call the if statement, but you won't do the expensive work, which is the loop. You'll get up to number 10, and when you try and add the 10th element, you're going to do the expensive work 49 to 53 one time, and that's going to cover you all the way up to 20. So that expensive work was only done once. If you were to not increase it by twice the size, but you were only instead of doing this, you did this like this. This is what you were sort of suggesting. Here's an alternative. Then as you filled up the array and you went from 10 to 11 to 12 to 13 to 14 all the way up to 19, you would be doing the expensive operation here in this loop, 51 to 53, every time you added something. And so the advantage of doubling the size of the array is that you only do the expensive work once as you're filling up the array after initial size up to the next element. I hope this is, I don't feel like I'm speaking super clearly, but there is a method to doubling it. And the basic idea of doubling it is you want to minimize the amount of time that you're using to copy the old data to the new array, but you don't want to over allocate your array either. Because the flip side, Josh, of your question is, why not make initial size really, 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 really big? And then you never have to call this method at all. And so what we're doing by saying 2 times data length is we're finding a balance between the amount of time we have to do the expensive work in 51 to 53 and the amount of memory that we're using for this object, because we can't make it infinitely large and we're using memory when we take it. So we're trying to balance that. And there's some mathematical properties that we like by doubling the array length size, but which is not being explained right now. So how's that? Is that a good starting point? A balance between size of the array and the amount of time you spend copying data around. Okay, so that I'm happy to clarify more if needed. Okay, so now let's tackle one more implementation, and what I want to tackle is one that we don't have a test for, and that is to remove an element. We've added elements, we've grown if necessary, we've checked if we've gotten out of space. Now what I want to do is I want to remove an element. And so what we can imagine is that we have a new test. Let's do test-driven development. How should remove work? We want remove to take something out of the middle and shrink the size of our array. So this new test is going to be called test remove, and I'm thinking through how it's going to work. When someone who is a API programmer wants to call remove, they might create a new array list. They might add Dodger and Billy the Gecko, and let's add Lucy the cat. We want to make sure that the size is 3. Now we're not really testing our new stuff here. We're just making sure that everything is good. And now what we want to do is we want to call a.remove element at position 1. So we want to remove Billy the Gecko. We haven't implemented that yet, so we're getting a red line. Once we've removed Billy the Gecko, we better have 2 elements in our array now. And furthermore, Dodger better be the first element. That's still good. And Lucy the cat better be element 1. So you can see that we manipulated this. We added Dodger at 0, Billy the Gecko at 1, Lucy the cat at 2. The size is now 3. We want to remove the element at 1. We want to make sure that size is 2 after the remove operation. We want to make sure the data didn't change as a result. And we'll just go ahead and keep removing elements to test. So now we'll remove 0. We'll make sure that the size is 1 as a result, that only Lucy the cat is present at position 0. We'll do another remove operation. Now the size better be 0, and we're not going to get anything because we know there's no data there. So this is a real nice basic remove operation test. Does 3 removes, doesn't do it all from the same position. The only thing that might be nice is if we were to remove something from the end position as well, but that's probably going to be okay. So let's implement remove. Oh, I guess the other thing is that when you remove an element, you want the element that comes back. So let's go ahead and say X is what we're getting back. And let's check that as well. Oh, we don't need to declare it the second time. We just use it. All right, we'll want to write a test to make sure that remove gave us the right thing. So we want to assert that assert equals that x equals, remove the first element, so Billy the Geeko. And x better be equal to that. And we'll go ahead, because it's an object, we'll force it to be a string. All right, good. And then down here, when we remove the 0th element, that better be Dodger that we get back. And down here, we better get back Lucy the cat. So this is just testing to make sure it's behaving the way we expect it to behave, not doing anything particularly helpful, not doing anything particularly powerful. Okay, and before we run out of time, let's see if we can implement this. So we want to remove elements, and the trick with remove is that we have to shift everything down after we're done. So the first thing that we're going to do is we're going to check to make sure that the user didn't trick us or make a mistake by doing a bad bound. So we'll check the bounds. And then we're going to capture the object that's being returned. So we'll call it object ret for return, and that's going to be data. I'm rushing here because I recognize we're running out of time. We're going to get the index position back, and now what we need to do is we need to shift everything down to fill up the spot that we just got removed. So we'll say int I equals index plus 1. That's the element 1 higher than the one we just returned. We're going to say while I is less than current size, we're going to go up to what we have so far. We're going to increase I, and we're going to say that data sub I minus 1, so overwrite the position that we just took data out of, overwrite it with the 1 right above it, and then finally we need to shrink the current size. And then we're going to return the element that we returned beforehand, and I think that's going to work. Check the bounds, save the data that we want to return, overwrite that element with everything 1 position to the right, shrink the size, and return it. And let's go over to our test, coverage as JUnit test. Cross your fingers. Yeah, great. Okay, so now remove works. And I have high confidence that it works because I wrote this test beforehand. And then when I went to implement it, I implemented it in such a way that it should be okay. So I have a lot of confidence that this works because I wrote a test, it passed them all. I can see that over in my object, almost every line has been checked. The only thing that we didn't check is we didn't have any sort of test that validated that check bounds would capture a poor choice. And just as our final thing, let's check test bad bounds. And so we'll make an array of we'll say a.get1. We know that's going to throw an exception. If it doesn't throw an exception, we'll fail. And we're going to catch the exception that was thrown, index out of bounds, exception E. If that happens, everything is fine. Great, and we rerun our test. Great. All right, so now you can see, well, you can see that we captured the array out of bounds. You can also see that we didn't test the negative one. Sorry, OCD, one more and we're done. -1, test bad bounds, 0.2, make this 0.1, run the test. I want complete coverage. Come on, complete coverage. Yeah, great, complete coverage. All right, perfect. All right, that's what we've got for today. Let me shift over to in-game. You're welcome. Double broadcasting. All right. You're welcome. It has not. Do you want me to link you in? Okay, so CS-030, we're broadcasting in YouTube, and we are down in the campfire. We're enjoying a class by the ocean. This is March 8th, Monday, and yeah, so we're done for today. Let's go windsurfing and then stop our broadcasting. Oh, someone beat me to it.